Today I'm going to be talking about a project I'm doing in Manchester, actually. I was born and raised in Manchester, even though I work at Queen's, and quite proud of being from Manchester, really. And the project is called the Biosci Project, but I'm going to talk more about the Biosci Foundation, which is the institution in which the project is held. And I have to say who it's funded by, because they'll kill me if I don't. It's funded by the Manchester International Festival, which is a biennial arts festival. And this is their... well, they came to us and said, we'd like to do a legacy project with you about changing the city over a period of, say, the next 10 years. And we were... one of my ex-students, Vinny Walsh, did an MA with me, and when he left, I said, what are you going to do, Vinny? He says, I'm going to change the world, Greg. So I said, well, that sounds quite an interesting thing to do. So we sat down and we decided that we'd do some guerrilla action. So we squatted in this building, and which is a small mill in Blackfriars in Salford. And we decided to set up the Biosci Foundation, which is part farm, part food business, part laboratory, part design studio, and sort of quite an interesting space, really. And the idea behind the Biosci Foundation was to change the world, really, through direct action. And what I'm really interested in is closing resource cycles in the cities, using waste as food to try and make a sort of new, sort of biogenic sort of city. And we thought we'd do this through what I call inspirational research by design, by actually doing stupid things that make people think. And also through this idea of, I really like Kevin Kelly's work, and one thing he says is the future won't be made, it'll be born. The new biological future is sort of technology and biology together. And so we looked at that. And Vinny himself, Vincent, is really interesting in community power and what you can do with how you can empower communities to really change things. So we decided to look at this area of Salford, which is actually in the bottom 3 council wards in the country for poverty and deprivation. So it's really miserable there. But the interesting thing is the mill is only 400 metres from Harvey Nichols, which is quite interesting as well. So you've got this sort of, Mount Everest of wealth on one side of the river with the sort of Java Trench of poverty on the opposite side of the river. So that sort of made it sort of more interesting, really. And we decided to start with changing people's perceptions of food, because from within a 600-metre radius of the building, you couldn't buy a vegetable, even though 17,000 people lived in that area, which is quite amazing. You can buy frozen vegetables, or you can buy, a quiche that's frozen, or a pizza with peppers on it, you know what I mean, out of a freezer, but you can't actually buy a vegetable. So we decided to start with food consumption and production. And the first thing we did was sort of try and close all the cycles of food in the neighbourhood through trying to make a sort of a farm producing things in the Biosci Foundation, and using various waste products like spent coffee from coffee shops, from landfill, land waste from Salford Council, ex-food from people who had out their green bins, and put this all through a series of systems, which were things like worm beds, mushroom production. We've even got a brewery going to be starting on site, which is going to produce beer for the neighbourhood. Very good, because we can use the waste from the beer process to feed our fish. And so we invented this sort of big system. We've got some bees in it that are going to pollinate our plants. And so we end up with this sort of dead mill at the moment, as you can see, built just after the war, and that has been a problem because basically it was made out of, all the steel in it is a random sizes because they just found them. I think to think. So that made it quite difficult to make the farm. And to turn it into this sort of laboratory space where people can hang out, and it actually is part of a food production thing. So, and the idea about the Biosci Foundation is that it's an open source research studio. So anyone who's interested can come and work there. You have to pay a very small amount to occupy the space because it costs us. Because we're squatting in it, makes it quite easy to make it cheap. And it's meant to be like a medieval university, you know, where you could just turn up and start researching stuff, you know, rather than having to pass exams to get in, you know. And so we've got academics from 4 different universities involved. So it's really cross-disciplinary. We've got ex-cons and scallies who've been busted for growing marijuana, helping us. Other ones who've been doing all sorts of misdemeanors you don't want to know about. And we've got people who've walked past who said, can I be involved? It looks interesting, who've just come in and done things. And we've got loads of interesting design practitioners. So it's a really interdisciplinary, collaborative space. And within that, there's a farm and an agricultural lab, which sort of, and the idea of it, it's relatively small as a farm, but significant. And it tests food systems. It tries to produce organic solutions that are closed cycle, that use waste products to grow things. And it uses the ideas of permaculture, about sort of a way of engaging with plants in a sort of natural way in an aquaponic system. But I'll tell you about that in a minute. We have the closed cycle food systems. We realised because there was no food in the neighbourhood, no vegetables, we realised we had to develop a food distribution system. So we invented this thing called the whole box, which basically at the moment sort of moves vegetables from wholesalers in the city through a sort of system of people who know about things in the tower blocks next door. And we give away, well, we don't give away, we sell about 150 food boxes a week to people who've never had a vegetable before. So that's been quite interesting. And we're opening next week a whole food shop. And the whole food shop is called 78 Steps because that's the food miles distance from our farm to the shop. And then what we do, we also get the waste products from the food back and we compost them using worms. And we feed the worms to the fish. And we use the compost on the forest garden that we've got outside. And we also are producing mushrooms using Costa Coffee's waste coffee grounds, which is a bit of a challenge as well because they're a bit wet, but it's working okay. So we have a forest garden. Vinny spent 7 years on a Rastafarian commune at some point in his life, which has created some issues personally for him. But actually, they farm in a sort of a forest, and so we're using this waste bit of land outside the mill to create this food-producing forest orchard thing, which is a 20-year project with Vinny. We're just planting it up at the moment, and that's going to sort of produce food in a 3-dimensional way. So that's one of the things, and I don't know much about that, to be honest. I've never really done Rastafarianism. But my thing is technical systems, really. I'm an architect and urban designer, but I've got really interested in food. It's quite interesting. As an architect, it's really easy to design urban farms, because what you do is you get a picture of the building and then you Photoshop loads of vegetables on it. And then you get £300,000. That was the easy bit, getting the money. The hard thing is actually building the system, you know. So... And we've tried to do it with, you know, trying to make it closed cycle. So we're growing worms to feed the fish. We're using waste food as well in some of the fish food because there's no point. Most fish are fed on fish. And the idea of aquaponics is you have some fish. They excrete ammonia. That then goes through a mineralization system that turns the ammonia first into nitrite and then into nitrate and then into nitrogen. And then the plants pick up that nitrogen and use it to grow with, and then the water comes back clean. So the system consists of aquaria, mineralization worm beds, and then a polytunnel, really. And so I'll go through each bit because we haven't got so long. So at the moment we've got 12 tanks because it's sort of an exhibition as well as a sort of farm and a laboratory. We've put the fish in separate tanks because we can break the system up and use it in different ways to test different sorts of things. So at the moment, we've got 3 species of fish in our system. I took this picture before. The fish have only arrived on Monday, so they're just getting used to being in the building at the moment. We've got tilapia, trout, and carp, and they're harvested every 9 months. So the farm makes about 200 kilos of fish a year. So which is a reasonable amount. The problem with all that weight is it's heavy. I didn't really. I should really know that, shouldn't I? As an architect, I should know how heavy water is and how much building. I presumed that an industrial building would easily support the weight of my fish tanks, but actually this building doesn't, because it was really badly made. So we've had to have some structural alterations done to the building, which were relatively cheap but difficult to organise. And basically the water percolates through the fish tanks, ends up in this giant sump. This is empty, and there's a pump there, and that then pumps the water through a UV filter to kill Legionella and other sorts of bacteria. And then it sort of siphons through this mineralisation bed, which basically has little clay balls inside each of these buckets, and there's 100 kilos of worms in there. And they're doing... The balls provide a surface for the nitrifying bacteria to live on, and the worms do the last bit of processing into from nitrate to nitrogen. So that's sort of a living filtration system. We've sort of invented that. We hope it works. It seems to be working at the moment, and you can see that each bucket has got an inflow, and then this siphon device that then, so the bucket floods, and then when it gets to the top, it then dumps it all into the next one. And then it starts again, because aeration is really important in the system. And then when it arrives at the bottom of that system, it gets pumped across the mill, and it runs down a second mineralisation system in the window. This is our tomato bay. So these silicon bags are full of basically clay balls as well, and tomato plants eventually. So they will start. They're being planted up this week, so they're starting to grow. You can see, if you look right at the end, some of the test ones are over there that have grown really well. And you can see those in close-up as this sort of thing. And what we tried to do is we tried to make the system, it's completely DIY in a way. We've made everything ourselves, from first principles without really buying any products. So to sort of hopefully inspire people to do similar sorts of things. And what we're doing is we're making everything we've discovered open source. So if you want to build your own farm, you can go on our website and work out how to do it. And from the window system, it then goes up onto the roof into this polytunnel, and there are 6,000 plants growing in plastic tubes. And there's about a 6-week cycle of those crops, averagely. There's about 4 weeks in summer to get a full-size lettuce or a full-size herb, and maybe up to 4 weeks in summer, 6 weeks mid-season, maybe 8 weeks in the winter. And we look to produce about 1,000 crops per week, which is a significant amount. And what we've done is, a lot of the interesting things about the system are that we have to, it's that actually the production of food isn't necessarily the hardest bit. It's actually the distribution of food. Supermarkets are really good at distributing things. So what we've done, we've made links with all sorts of expensive restaurants in the city to maximise our prices, so that we can then sell things expensive to them, and then the stuff we don't sell, we sell cheap to the locals in the whole box. So we've tried to make a system that works. The amazing thing is, people have been really generous. For example, Siemens have built us a control system, which is for our pumps and everything, which is complete overkill. But it's about, we just were going to have plugs with the switch on. But they built us a whole system. And they've actually made us a remote monitoring thing, which actually anybody will be able to log on and see how the system's working, how the chemicals, or the nitrate levels, or the oxygen levels, the temperatures in the system. And that's going to be really important, because we've already got commissions for 2 more farms, and eventually we'll need to be able to control them from somewhere. So they've been really good on that. And then we also managed to blag 75 square metres of second-hand photovoltaics. And we saw that the tower block next door had photovoltaics on, and they were taking some new ones up, and we said, what's going on? And they said, we're putting new photovoltaics on the building. These ones are 3 years old. So we said, thanks. So we've got those now. So we're carbon neutral as well. And this is basically what the system looks like. So we've got the garden. We've got the mushroom production happens on this floor with the exhibition space. The fish tanks sit around here. The mineralisation's here. The window system's there. And on the roof, we've got the polytunnel. We've got chickens and bees as well. And a few other bits and pieces in there. And the interesting thing is that quite a few big companies have come to see us. And we've now designed This is a facade for Waitrose that we've designed, a food growing facade for one of their supermarkets with building design partnerships. So we're sort of trying to get them to produce their food inside the shop, which I think will be quite interesting. Okay, thank you very much.